basically Autodesk is supporting all the different teams in terms of doing this. So what we're doing is going to be making software available for all the teams to work with. We're also going to be just putting a lot of different materials out on the web, really have a whole portal available so that teams can go ahead and find learning materials, instruction about how to use the software. And I hope that we're going to be doing a series of different webcasts, all just really about how you apply the tools to some of the different solar Decathlon products and like the workflows that you need to be supporting. So let's just go ahead and dive in and get started. And so we can really, what I'd love to do today is give you a little bit of a whirlwind tour of the whole, Autodesk building design suite, introduce you to some of the tools that are in there and get you thinking about really how a lot of these tools can be applied to sort of create some of the different deliverables that you're going to be responsible for. So let's go ahead and dive in and get started. Now, it all starts with the notion of building information modeling. That's really kind of the core of a lot of what we're doing with the building design suite. And at the heart of that concept is really the notion that there is a building model. That's a model of all the elements that are going to be part of the building project. And we're going to go ahead and create that model, sort of in the sense of how we typically model things in an architectural world. But that model actually contains a lot of information that's going to be useful for supporting the entire range of different building activities. So, for example, taking a look at the conceptual design phase, we can use that model to do a lot of very early analysis to understand whether we're siting the building properly, whether we're orienting nicely, just really how the window glazing is working. We can analyze that model to really understand the energy performance, the daylighting that's entering the building. Things like that are typically going to be useful for the solar Decathlon teams. We can also just go ahead and actually simulate the construction process so we can really understand the constructability and how the whole thing's going to really go together out in the field and create all the working documents. So not only are we creating sort of an architectural model, but the same model is going to be used to generate the working drawings, the details, the plans, the sections, everything that you ultimately need to submit. Now, in the full building information modeling world, we also think about possibly fabricating out of the model and even operating the building using the settings that are in the model to help control the control systems and by just monitoring things and kind of adapting things dynamically. That won't be so relevant towards the solar Decathlon houses, but it's really the big picture of what we're thinking about doing with the modeling. And then as we think about that, there's this basic notion of a workflow and different deliverables that you have to go ahead and provide. And we're going to talk about some different deliverables that are really going to help you through all the different phases of your process. Because as best I understand it, and please chime in, like if it's a little bit different in your process, there's some conceptual design deliverables where we're going to go through it at a very schematic level and understand the performance of the house. We'll get into the detailed modeling of the architectural systems primarily, but you could also model the structural and mechanical systems. We'll be looking at visualizing, so creating renderings and visualizations to actually understand the visual appearance and just really communicate the design to other folks. We'll be doing some analysis with the model, really kind of understanding what the energy performance is and predicting what the energy performance is so that maybe we can monitor that in real time with the finished house, producing some construction documentation. And in the US, we even have a requirement for on the construction planning side to go through and do a quantity takeoff so that they can do an estimate of really what the house is actually going to cost to build. So I think your process is fairly similar to that, but if it's a little bit different, let me know and we'll kind of adapt our comments accordingly. Okay. In terms of thinking about this, really, even at the conceptual design phase, there's a couple tools, and really what I'm going to do is just kind of walk through the different phases and kind of let you know about the different tools. For the conceptual design phase, when you're just getting started, there's really this whole notion of a tool called Vasari, which is really, really very good for helping you through that. And it's very good at doing conceptual energy analysis, shading and solar radiation, even wind tunnel simulation. And this is something that you can start using really from square one before you even have a very good idea of what the house is going to look like. And let me kind of just take you to Project Vasari so you can get a sense of what that looks like. Let me roll on over in my screen. Project Vasari is actually really a subset of the tools that are available in Autodesk Revit and kind of put together with tools that are available in Ecotect Analysis. It's actually sort of a hybrid of a couple different tools. But the idea is, and let this go ahead and pop up there, we can very quickly go ahead and model some sort of shapes. Now, when we're doing energy analysis, it always starts with the notion of we do need to go ahead and put in an accurate location so that we have good latitude and longitude, so we get good climate data and understand just really how the sun's going to be oriented in the sky. So in this view over here, you can see that actually I have the house currently located in Wollongong. If I want to go ahead and change that and actually shift it over to China, where I believe the house is actually going to finally be located, we can go ahead and do that. What it does is it goes out to the internet, and it really just uses Google's like internet servers to go through and locate weather stations. So we can type in addresses, choose a weather station, and just grab information. But I won't change that now. We'll leave it at Wollongong for right now. When you're starting to create conceptual masses, the idea is early on, even before we've done a lot of detailed design, we might want to think about the shape, the form, which way things are oriented. And just to give you a sense of what it's actually like to work within Vasari, let me kind of give you a real simple example. If I want to create a new mass, some sort of new shape that I want to put on the site, you'll see I have an existing one there for some preliminary ideas I had about what this house might look like. I can start by just basically drawing some basic forms, using some just drawing tools. Let me go ahead and I'll just make sort of a very basic rectangular box right now. I will click on that and actually just stretch the form up a little bit, give it a little bit of height. And then if I want to start having sort of a more interesting shape, I want to have a sloping roof, or I want to go through and kind of change the walls so they slope, I can start pushing and pulling on the different surfaces. Okay, and real quickly I can start to sort of just get a sense of the overall form that I want to try to create. When I say finish the mass, that's actually going to be considered as a building form. So you'll see I actually have a building form right next to it. This was sort of my preliminary idea for what I thought my solar house might want to look like. What I can do is, if I go ahead and choose that form and say that I'm going to put a mass floor under it, that's really saying that it's going to be building area. Okay. We can actually start to go through and adjust the different surfaces, think about the different window characteristics. Let me go ahead and I'll just take that one out and we'll keep on working with the previous one over there. And let me see if I can get rid of that now. Why don't you want to get rid of that? Let's come back over here. Oh, let me come back. Oh, I'm modifying a mass zone. Hang on. Let me pop back out. See if I can get rid of that. I'm going to think about why I'm not able to get rid of that in just a second. Well, not to worry. We're just going to keep on going. The idea is that once you've gone ahead and created a form, we can start adjusting the characteristics of that form pretty easily. For example, you'll see on my little model over here, I've actually put some windows in and put them in kind of some specific locations. Vasari tends to think of things in terms of different ratios of window to wall. So you'll see that on the north side, I put some big windows where I think I might want to try to capture some sun throughout the day. On the south side, I put some smaller windows. Okay, on the back of the house. And if I want to try to understand the basic house and its performance, I can do a couple of different things. Okay, one thing I can do on the analysis side is I can just do a solar radiation analysis very quickly. Well, let me go back to the other view so I can do that. Okay, if I do a solar radiation analysis, let me kind of show you how it sort of works. That is, we can choose the faces we want to analyze, so we can choose some specific faces. We could also choose a time frame, whether I want to do it for the summer, the spring, the fall, or really the whole year. Kind of depends on what you're after. We can go through and say whether we want to look at things cumulatively or just on a spot basis. But when I go ahead and close that, you'll actually see that we're starting to get some data back in terms of just really what the amount of insolation, what the amount of solar radiation that's actually hitting the house on the different surfaces. So the darker surfaces back over here on the south side isn't getting very much sun at all. The roof is actually getting a fair amount of sun, so that probably will be a pretty good solar collection surface. You can sort of see that the west face, you know, the east face is not getting very much, but the west face is actually getting quite a bit, and the north is getting the most. So we can start to understand buildings that way. We can also go through, though, and start looking at what I'll call the conceptual energy analysis of the building. And how that works is for these different forms, if, for example, I choose this building, and I say that on that surface, I want to go through and put in a certain percentage of window to wall, I can put in a percentage, let me make that maybe 50% window. And then I can even choose whether I'd like to put some sort of shading on that window. Okay, and very quickly I can start getting results back from this. Now I've only spent just a few minutes kind of creating this basic building shape, but let me show you what you can actually get out of the process. So we can set up some energy settings about really the type of use and the type of HVAC system or mechanical system that might be in the building. But when we say run the model, we'll say analyze the mass model, but I'll just go over to the results so we can sort of see what it's actually producing, just in the interest of time on this whirlwind tour. Let's see if I can bring that up. Okay, I've actually run that basic model from a couple of different orientations. So what it actually shows us is, for the basic building model, it gives us some data based on the weather station, about the floor area, about the cost of the utilities in kilowatt hours and for therms. It's also giving us a very nice figure called the energy use intensity, which is a really good normalizing factor for trying to figure out how much energy is being consumed by the building. So here it's basically looking at, if I have things facing to the east, the primary windows facing to the east, it's 69 kilobtu's, 79 or 76, 79 probably being when they're all facing to the north. Yes, because there's an awful lot of sun coming in. So just in a very short amount of time, we can get some very good feedback about not only the energy use, we can sort of think about what the potential for photovoltaic generation is based on the efficiency of the panels. You can sort of see where the energy is going in terms of how much of it's going for electricity, for heating and cooling, and really what the net carbon footprint of the building is. Okay, or the potential relative to the solar energy. So the way it looks right now, it's interesting. That one actually has a -2. That's actually zeroing out more or less. That one also is about a -2 right now. So what Vasari is very good for at a conceptual design phase is it'll give you numbers that look like, oh, the total energy going to be consumed by the building is like $21,958 across the lifetime. Now that's not really a very valuable number. It's sort of a prediction over 30 years, but don't bet your money on that one. What it is very good for is doing comparative analysis. So, and the idea with Vasari is you can start to look very quickly at different building orientations, different kind of ways of massing the building, different positionings for the windows, get some very good feedback to get yourself started in a very informed way. So I just want to let you know about Vasari as a starting point, because it really is a good just starting point to get you going on the entire process. Okay, let me switch on back over. We'll say, once you've kind of looked at things in terms of Vasari and you have some basic idea what your conceptual design looks like, you probably want to go ahead and move into just more detailed modeling. And when it comes time for detailed modeling, probably the best tool to be using in the suite is Autodesk Revit. Okay, there are tools in there for modeling the architectural features, the structural features, and the mechanical features. And let me kind of take you a real quick tour of really what Revit looks like. Okay, Revit in a lot of ways looks an awful lot like Vasari because they are very closely related. Okay, this, for example, is, this is my take on what might have happened if I just developed my design a little bit more. So what I've done is I put together a basic little building model here. This model is sort of based on, it's kind of loosely based on some of the designs that were recently in the US competition, with a butterfly roof and a lot of glazing on some of the different sides. And within this model, you see I've actually started to go through and put a lot of different information. I can look at it in the floor plan view, kind of look at it in terms of all the different rooms, put furniture, figure out what the areas of the rooms are, really start doing a lot of design for that. But the beauty of the building model is not only do I have the floor plan and that 3D view, but I also have things like the elevations being created for me. Okay, and they're all out of the building model. And the nice thing about all these different views is if I change anything in any of these views, for example, if I would take that door out, which may not be a very sensible thing to do, but let me do it just for the purpose of illustration. If I take that door out here, can remove it, you'll see that it's actually going to go away on the north facade also. Okay, it's also going to go away in the floor plan. And the beauty of information modeling is that as we go through and make a change anywhere in the process or anywhere in the model, it's really reflected everywhere else. Let's go ahead and put a door back in there. It'll make me feel a little bit happier in terms of what's going on. So I'll put a single glass door in there. I'll put the 36-inch one in there. I'll just drop it right in the model. I can flip that around if I want to. Okay, and then when I go back to the 3D view, you'll see it shows back up again. Now, the information in the model is not only there visually, but it's also there actively. So we have all this data about the different elements in terms of all these properties of them that we can summarize in schedules and tables and really use them for analysis. So the idea of the modeling is really just the starting point of this. And as you go through and do your modeling, it's going to start with basically doing the building elements and thinking about the surfaces. For example, each of these different walls has a structure to it. It has kind of a layering to it of all the different materials that are in there and the thicknesses. And one of the really cool things that's actually happening now in Revit 2013 is these wall assemblies are actually very smart about the thermal properties. So for each of the different materials, we can actually assign, what the U value of each of the different materials is, or actually it's the, it's the thermal resistance. And then what'll happen is it'll go through and like calculate a composite U value for the wall based on the actual thicknesses. So it's really getting quite smart about sort of saying it's not just an architectural model, it's also an analytical model. Okay. Other things that are nice about the modeling process, we can go ahead and model structure. We could also model mechanical systems. So even things like, the plumbing fixtures, the toilets, the sinks, things like that, we can actually start modeling the piping and the plumbing and pull that all together so that if you want to start thinking about a building that has either a rainwater collection system or maybe a gray water system that's collecting some of the water for reuse, we can actually model that accurately and actually report out the true values. So it's really just sort of incredible what you can do with this modeling. I'm just merely scratching the surface, but I just wanted to give you a sense of really kind of what's available in there. Now, these models also are very good for doing things like visualizing, so let me kind of show you here. Even in kind of a real, very basic sense, we can do things like, let me open up something called the section box, which lets me do things like, just create dynamic sections. So I start to conceive about how the building's actually constructed and what the elements are inside. Okay. We can also do things like, just in a very simple sense, if I want to go through and put a camera in so that I get a sense visually of really how something's going to appear, I can do that. For example, I'll put a camera over here on this side of the room, sort of facing out that way. Okay. And I'll get a really quick visual indication of really how things are working in that room, so I get a good architectural sense of what that room is like. Same thing for the exterior views. Okay. So, in terms of doing your building modeling, Revit just is going to do a very good job for you there. It's definitely worth the time to go ahead and invest a little bit in learning Revit because there's incredible power in that program, and you really want to be able to tap into that because it's really the core of a lot of the other things you're going to be doing. Okay, let me go ahead and go back into the overall workflow again, though, to kind of put it back into perspective. Because Revit's kind of the heart of that world, but after we start working with Revit, there's some other things you might want to do. For example, a lot of what we do tends to revolve around visualization and how we actually get things to sort of appear and kind of look appropriate, so we can actually sort of represent our designs well. And there's a couple of different tools I want to let you know about. So there is, right within Revit, a rendering engine, and we can do some things that are very simple within Revit to sort of do the visualization. Or there's some other tools like Autodesk Showcase and 3ds Max Design, which let you do some very cool things too. So let me go back to Revit for just a second. And I'm going to start by just going ahead and showing you kind of real basic visualization within rendering, or within Revit. So for example, let me go back to that 3D view. And even what may be a little bit better here is, let me do this. Let me do it as a camera view, because I think that's a little bit easier to understand in terms of what's going on. I'll put a camera over here facing the building that way. Okay, these views are sort of, kind of very basic in terms of what's going on, but they're not really as realistic as you might want them to be. We can do things like turn on the shadows and actually start to understand how the shadows are going to fall at different times of the day. We can also sort of play around with some different visual styles here. So we have things like shaded views, which give you a little bit of color information. There's a really nice feature built right into Revit called realistic viewing. And what realistic viewing will actually do is go through and give you a real quick indication based on the actual material properties. So if there's a photorealistic material, for example, the siding on that wall, it'll represent that accurately. And we can start to very quickly just get a sense of what this is going to look like from a visual standpoint. Okay, let me go ahead and kind of look at that a little bit differently. Okay, so we'll do that. Okay, we can also do things like, just put like a background behind this. For example, In the sky, if I'd like to go ahead and have a little bit of a gradient sky to it or something like that, I can give it a little more kind of depth to kind of make it a little more visually evocative. And in Revit 2013, you'll see that we can actually put a photograph in there, so we can actually put the building into context. So there's a lot of basic visualization power available right within Revit, and I'm going to promote doing the visualization within Revit whenever you can, because then you have this really direct connection. As you model, you can see what the impact is, and then as you're seeing what the impact is, you can start changing your model and just do it very, very fluidly. Have a very nice interaction between those things. Okay. However, when it is time to go ahead and sort of just really do things at a higher level of quality, there's some other really cool tools you can take things to. You know, as you take things to other tools, one of the primary ways we do renderings or sort of visualization is using a file format called FBX, which is Photobox. Okay, so we can export things as a Photobox file, and that FBX file is something that we can then bring into either Showcase or 3ds. Now, I'm sure what I want to stress about all this is the good news is we have like a workflow of things flowing through. So although we're modeling in Revit, your model can come right into Showcase or 3ds Max. You're not losing anything along the way. We don't have to recreate the model. The idea with the whole building design suite is that we should have information flowing through. You can do your visualization, then as you update the model, we can update the visualization, and everything will work very nicely together. So let me kind of show you Showcase, just because it's a really cool tool, and I think you'll want to use that as a starting point to get going. Okay, here's Showcase. This is the FBX model, the model that came in from Revit, and you'll see it looks pretty much like what we were looking at before. The nice thing is we can go ahead and orbit around and kind of play with it, but I'm not sure if you can sort of see right away. It's a little graphical goober there, kind of in terms of the lag in the screen. It's actually very good on shadows and light. It's actually doing a very good job of representing it. This is really kind of real-time rendering, so it's not just shading, it's actually putting the materials on there and doing kind of a really kind of quick sort of ray tracing to kind of give you a very nice visual appearance. Now, what's really cool about Showcase and the ability to kind of do this kind of real-time rendering is we can start playing around with things that really let us start to control things. For example, one thing that we might want to do is just start playing around with the issue of, oh, this wall surface and whether I like that type of siding. What I can do is basically select all the objects that have that material. I'm going to open up a material palette and kind of pull up some different standard materials that are available in the library, and these are the same materials that are available in Revit as well as in 3ds Max. So if I wanted to go through and try some different sort of appearances, I can do things like, okay, let's choose siding. Let's try it with, oh, standing seam copper. Or that didn't look very good. How about kind of a wood that looks something? Let's zoom on in and see how that's looking. Maybe a nice vertical wood surface. Board and batten. Maybe shingles. Okay, but what I'm hoping you're sort of getting at as I'm playing around with the model here is this notion that I really am playing with the model, and I'm trying to really understand the visual appearance and that, and there's something about the fluidity with which I can go ahead and do that that really makes it kind of very easy to go ahead and get started and just understand what's going on. Now, the really cool thing about this environment, there's a couple things that I really like about it. One is there's this whole notion of basically it's different, let me kind of bring them up. No, it's not shadows. That's not what I want. I want to bring up design options, alternatives, okay? And I can actually stash away, store different design alternatives so I can really quickly evaluate them. For example, I created some design alternatives already that would let me sort of explore the model in terms of saying, well, let's take a look at this siding versus that siding versus this one. I could also say, well, let's take a look at some different roofing materials. How about like a standing seam metal roof? That's a Spanish tile roof. That's kind of a different sort of tile roof. But I'm able to go through and combine together different effects very quickly and just sort of evaluate what the overall effect is going to be on the house. So, yeah, this is sort of real time in terms of what's going on. I can go ahead and change my orientation as I need to. I can even do things like, let me do this. I'll move inside the house. I'll walk inside the house. A little high up right now as I crash through that window. Let me pan on down. So we're looking a little bit better. A little close to the floor. Now let me go just looking around. So I can kind of see into the kitchen area, what's happening there. Now this model's pretty early on in the process, so I haven't really developed it very much, but I hope you're getting the sense that I can start understanding and seeing what's going on here pretty quickly. Let me pull back out again. Another thing that's really nice about Showcase, and I'll finish up with this one, is the notion of immersive environments. How that works is you can go ahead and take this building and actually place it in a context. So for example, if I go through and bring up the environment library, I can say, let's take a look at this if the building was actually in the middle of a grassy field, for example. And actually sort of see the effect of the building in the context. Now, if that's not what you had in mind for your building, you really were thinking about it being sort of more out in the desert, okay, or somewhere out there on a dry lake bed, or really wherever it is that you want to go ahead and feature your building, okay, you can go ahead and do that really quickly too. And really, as a presentation tool, it's really hard to go ahead and beat working with Showcase. Now, since I already have a new ground plane, I probably want to take that one out. Okay, and now the building's actually sort of, the house is floating right on top of that. So, you know, a lot of cool stuff. Just kind of just want to make you aware of some of the different things that are available there. Okay, let's go ahead and switch on over though, because there's more to what we need to do than just visualization. I want to kind of tell you about sort of more the active computation side of what's going on too. So let me switch on over and kind of show you that. Okay, in terms of analysis, really the best tools that you want to be thinking about are Ecotect and Green Building Studio. So again, two different things. Ecotect is actually available for you. It's available from the student community site. Actually, we should talk about that in terms of making sure you have it access, because it's not, I don't believe it's actually part of the building design suite, but we can get access to that for you. And there's Green Building Studio, which is an online service that's available for doing analysis, that's also available to you because you're part of the student community. So you'll have access to that too. So how those look are something like this. Let me go and switch over to Ecotect and show you how this works. Okay, I can go to Revit and take my basic model. Okay, and here's my little developed building model. Let me go ahead and kind of put that back into sort of more of just a shaded view. Okay, and export it in a special format called GBXML. And GBXML is Green Building XML. It's just a text-based file format that transmits the thermal data and the surface data, so you can go ahead and use it in some other programs. So GBXML is a very nice universal format. What we can do is go through, and if you bring the building into Ecotect, you can sort of get a very simplified version of the building, which looks something like this. Now, this is a little abstract. I hope you sort of recognize that as being about the same building. We have sort of the basic window areas in there. We have the big curtain walls across the front. We have the doors and the basic roof shapes in there. And this is enough to go ahead and get us started in terms of doing some energy analysis. So a lot of things we can do here within Ecotect. It's very good on doing thermal analysis. It's good on doing daylighting analysis. But relative to the solar house competition, one thing I really want to kind of show you and make you aware of is a really cool tool called just solar ray bouncing. So let's kind of show you what that looks like. I can start by just sort of displaying shadows. So there's a lot of different tools in here. One's the sort of the sun tool, and I can display the shadows and kind of change the shadows as we move through different times of the year. Now this is actually taking a little bit of reorientation for me, because I'm used to June actually having the sun very high in the sky and December being the opposite. But here for you, June is actually the long shadow months and January is the short shadow months. So we can go ahead and kind of choose a specific time. We can also look at different times of the days. We can also do things like just display the daily sun path. So we have a little bit of a solar heliodon, and we can go ahead and move the sun in the sky and really just start to understand what's happening with the shadows and how things are being cast to the building. And that's a pretty good starting point for getting going. But let me show you something that I think is even a little bit cooler, and that is, let me go back to the 3D editor, which is kind of more this semi-transparent view of the house. Okay, and what I've actually done is I've taken some of these surfaces, like the wall surfaces and this little surface right here. Let me show it to you back over in the visualization tab. And the idea was I put a little light shelf in there because I wanted to go through and try to bounce some sunlight off of that shelf into the room and really see what the effect of that would be. So I'm trying to do a little bit of shading with it, but I'm also trying to bounce some light in and increase our daylighting potential. So if I go to the 3D editor, I choose that and I say, let me show the solar rays. You can actually start to see very accurately what the effect of the solar rays is. So here we have the solar rays. This is in May, around 1 o'clock in the afternoon. Let's take a look at in January. In January, when the sun is very high in the sky, notice what's happening here. It's actually the solar rays are coming down, they're actually just bouncing up and hitting the ceiling, but they don't actually penetrate much further than that because of the way the ceiling slopes. So they don't actually sort of go back into the house at that time. That might actually be sort of a good thing because during the summer months, we don't necessarily want to get all that light in, or, have all the solar rays in there, which might heat up the room. If I go to June, though, and more to the winter months, I can go through and take a look at like the solar rays bouncing in. And here you can sort of see the solar rays, bouncing off of the light shelf, then bouncing up into the ceiling, and then actually getting back into the back of the room. Okay, and again, we can do this we can change through the different times of day, look at how the solar rays are bouncing around. We're very late in the day, early in the day. And actually sort of really understand what the effect of that is. And there's sort of a real power in that because you can really get real analytical results to understand really for each different design feature you add, really what the impact of that's going to be. Okay. Another thing that's sort of a really nice thing you can do within Ecotect is the whole notion of actually doing an analysis. So for example, in that room, if I'd like to try to understand, just really what the amount of daylighting is that's hitting that room, I can choose that floor. Basically say, let me go through and position a grid within there. I'll just put it within the room. Okay, that's a daylighting grid where we'll do a little bit of analysis. And I can actually go through and compute the lighting level. Let me just skip this wizard right now so that we can kind of get on through it quickly. We'll say okay. But basically, it's going to go through in that room, do an analysis of all the different squares of the room, and based on the lighting that's coming through that window, just really tell us how many, in the US we say foot candles. I'm not sure if you say lux or lumens on your side, but just really figure out really how much daylighting is hitting that room in the different locations. Okay, now this room has an awful lot of glass in it, so I don't expect we're going to have a very big trouble or a very big problem with daylighting in the room, but it'll give us some real numeric values. So, okay, the analysis is done. Let's zoom on in there and take a look. I can show the node values if I want to and the contour lines. And what you can basically see is that here near the front of the window, we have about like 20% of the full daylight, but by the time we get to the back of the room, we only have like 5 or 6%. Now, it's still a pretty good daylighting level for a daylighting factor. That would still meet LEED compliance in the US. If we look at it in terms of the actual number of foot candles, we can actually go through and look at that too. So just get real numeric values. I can tell you that in the back of the room here, it's getting somewhere around 45 foot candles, which is still considered a fairly bright room. That's naturally daylit very well. Out here by the window, it might be getting a little bit hot and intense though. So you want to watch out for that. So again, the big point of this is that with Ecotect, it's really good at giving you numeric, data analysis. It's really good for getting to the science behind this. I've been looking at it in terms of daylighting, but we could do very similar things thermally, so we can understand really the amount of solar radiation hitting any surface and analyze our panels, which might be the good locations for solar panels, or just think about any place we might need some extra shading or thin films or something to sort of protect us from the sun too. So a lot of good value in Ecotect. Okay, let me go ahead and close that up. And we're almost through with our whirlwind tour. Let me go back over to, we're getting close to the end of the process. In the documentation side, you need to create things like plans, elevations, building sections, schedules and tables of the different elements. For that, just go right back to Revit, because within Revit, you have the plans, you have the elevations, and what we can even do is in these things go through and create things like, let me give a section cut through that building, just by putting the section cut right in here. So now we have the section cut in terms of what's happening with the building. I can turn that up to a finer level of detail so I can actually see the different layers of the building. And I can even do things like, do a call out of a specific detail. For example, let me do a call out right over here. So we can really start looking at that detail and just adding more details to it. We can add drafting and detail components to it, adding anchor bolts, base plates, whatever it is we need to do. And the idea is that we're trying to basically generate the construction details just right out of the model, so you don't have to kind of do drafting after you've already gone through and done the modeling. So, think about really how, if you accurately model, you can actually create the construction documents you need and do that accurately too. So really a big time savings there, and really make sure that your construction documentation is always accurate. Okay, last up, but certainly not least, is the whole issue of construction support. And again, I'm not sure if it's a requirement on your side, but here in the US, all the teams actually have to do a quantity takeoff, so we can do a big model-based takeoff of the building. And there's a fantastic tool for doing that called quantity takeoff. Okay. There's also a very good tool called Navisworks Manage. I won't show that today. It's good for doing 4D construction simulations. But let me give you a taste of really what quantity takeoff is good for, just so you get a sense of that. Okay, let me do this. I'll pop out of here. Let me come back over here. Let me go back to the desktop and find where I put that. Okay, and right here, I'll open up a project. Now, the way quantity takeoff actually works is we start by basically just in your Revit model. Again, we're going to take your active model, and to do a quantity takeoff, what we do is we do an export of something called a DWF file, which again is just sort of another standard common file format. So we can export the model and bring it into quantity takeoff. And when we do, we get something that looks like, oh, let's see where it went. There it is. Okay, there's the basic model kind of sitting in quantity takeoff. You might recognize it as being sort of very similar to the same model. So if I can pop out of that. If I orbit around, kind of take a look at the model, you see it's all there. The nice thing is all the elements that are in the model are here quantifiably. So we can take a look at the windows, the doors, any of the different elements that are in the model. And if we want to select any of those elements, we can come over here and kind of choose them. So I can choose any specific element and kind of highlight it in the model. But what's really nice about the quantity takeoff is we can actually just say, let's do a takeoff of the quantities in the model. And what happens when you do that is it pulls all the different elements, and they're showing up over here in this pane. Or for example, for all the different walls in the model, based on the different types, it's really just sort of itemized them all. So all the different walls, and within each of those different walls, the area, the size, the length, all those different things is available to us. So you have a quantity takeoff that's accurate to the model quantities. You never really have to worry about making a transcription error. If it's in the model, the quantity will be there. If you update the model, the quantity will update itself also. So the way quantity takeoff is used is for each of these different elements. We can, like, for example, choose those interior walls and say, really, well, we have all the interior walls, but really, how do we take those off? And typically in the US, we do walls by area. So we'll choose area. We can say that, oh, the material cost for the interior walls, oh, it's going to be about $10 a square foot for the materials and about $15 a square foot for the labor. Again, the tool's not going to tell you that. You still need to have your cost metrics, but the quantities will be accurate. When we say OK to that, what happens is the item actually ends up showing down here in the takeoff. It's actually in the workbook. We see the total quantity of all the interior walls, the total quantity of all the exterior walls, and a little spreadsheet layout that'll let us go through and kind of see what the actual cost is. So how that works now is, now if the quantities are here, if it turns out that we need to change something, for example, you find out that for those interior walls, it's not going to be $15 a square foot, but it's going to be something like, oh, $25 a square foot. I can just type that in there, the number will multiply through, and it will roll up into the new revised cost. So the idea with quantity takeoff, again, is really you can take your model, focus on designing your model, and then get an accurate quantity takeoff of all the different elements without having to worry about doing a manual transcription of all that. So real power on that end there, too. So let's go on back and see if we can put this all back into perspective, because I know I have just dumped an incredible amount of information on you, and like your head's probably spinning thinking about like how all these things might work together. In terms of some of the resources and some of the things we've talked about, there's one very important site you need to know about, and that's students.autodesk.com. And I think that actually you're going to get some sort of either a CD or some sort of software distribution coming directly to you. Actually, now it seems to come on a USB drive. But if there's any of these tools that you want to work with that aren't directly available to you, for example, Ecotect, I don't think is part of that USB drive, you can download it here. So just log into students.autodesk.com, create an account for yourself, and download whatever you want. And you can get access to all these different sort of software titles available for you. Okay, another very good site for you to know about is projectvasari.com. That's really where that conceptual modeling tool Vasari lives, and a whole lot of a community that really discusses that, is available, and kind of like for interacting and sort of, working on customizing your project. So Vasari is a very good community for you to know about if you're interested in sustainability and energy analysis. Okay, there is a sustainability workshop you should know about, and that includes videos about net zero energy buildings, life cycle product costs, a lot of different things that are probably going to factor into your design. So there's videos, tutorials, case studies, a lot of good information for you out there, as well as this something that I actually have to work on, which is called the BIM curriculum. You probably want to know about the BIM curriculum because in terms of learning some of these different tools, if you go to the BIM curriculum, you'll actually find a whole series of different video tutorials and data sets to help you get started. So for example, if you want to know about doing daylighting in Ecotect, there's a whole lesson to it here. There's like short videos that sort of explain how to do things. You can play the videos, you can work with the example files and really get some guidance about how to do that. So it's a great way to learn on your own. It's just going to go right to the BIM workshop, and again, you'll find a whole session on green building design as well as kind of performance-based conceptual design, and that's more about the conceptual design phase and how to use Vasari to kind of start with your preliminary design of a building. Oh, down here in the construction section, model-based estimating, a good tutorial on that for you also. Okay, the big thing we want you to do is think about how to get yourself started, and the steps that are essential are get yourself into the education community, register yourself so you have access to all this stuff, download the software you need, and then really start learning about the software through the BIM and the sustainability workshops. Those are good places to start. Again, we're going to try and set up a portal to kind of pool and kind of gather questions from different solar decathlon teams and post things that we think are going to be useful to you. So we'll be sending you some more information on that a little bit later in terms of how to participate in that whole community. But the big thing is just go ahead and get yourself started, and we're here to help you work through that entire process. So don't be shy, and get in touch as you need help. Well, actually, and anything that we talk about will actually be ultimately benefit all the different teams, because we'll always do things in a way that really makes it generally accessible and share it with everybody. Okay, so let's go ahead and just kind of turn it open. So Brendan, if you want to open the mic on your side, and let's just take any questions people might have, because I know I've just thrown a whole lot of information at you, and we're interested in anything people might want to ask about.
Okay, thanks, Ben. Can you hear us this end now? I just turned the microphone back on.
I can hear you just fine, so go ahead.
Okay, so I'll hand it over. Please feel free to step up and ask a question. And maybe talk from there. Glenn, if you can't hear us, we'll get them to come towards the microphone at the front of the room here.
I have got two questions.
Okay.
First question for first question for solar Decathlon project. If we need to assess balance between energy consumption and energy supply, such as renewable energy resources, PV panels, and so on. I'm wondering if Ecotech has incorporated renewable energy assessment, and how will Ecotech support such balance analysis?
Okay.
Second question is about location setting for solar access and day lighting access, because the solar Decathlon house will be, our entry will be in China, in Decathlon city. If we can set up the local context through Autodesk product, like the local weather condition, local so on. So get solar access and the lighting analysis to be tailored to local context.
Sure. Let's go ahead and see if we can answer some of those for you. Okay, so in terms of the whole issue of renewable energy sources and really getting support for that, you can get some of that information from things like Ecotech. Like Ecotech is good about, it'll report the amount of solar radiation hitting a surface, But actually, if you want to go a little bit further, let me even sort of recommend a slightly different tool for you. And that's the other one, the one that's called Green Building Studio, which I think is actually very good for doing that. Well, actually, let me go back over to Vasari for just a second. Because actually, Vasari and Ecotect and Green Building Studio are always very closely related. So let me come back over to the basic report over here. So even in Vasari, from the very beginning, there is some sort of notion of like if there's a photovoltaic system potential. Okay, there's also this notion of really if there's some sort of potential for wind turbine generation for getting power. Okay, and those are some based on some, fairly general assumptions. If you really want to start digging into those assumptions, though, the tool to go to is Green Building Studio. And what you'll find in Green Building Studio, actually, let me see if I can bring it up for you even, is that it goes ahead and actually does, on the photovoltaic side, a very good job of analyzing. What it does is it even goes ahead and says for each of the different surfaces, really what is the photovoltaic potential, and really what it does is it analyzes kind of the generation potential based on the geometry. There we go. Okay, well, no, that's not it. I'm very bad about remembering all my URLs. Okay, it not only analyzes sort of the potential for generating different things. In fact, let me even kind of bring up your project and show you. So here's, for example, the one that's east facing. We can go ahead and take a look at this in terms of the photovoltaic analysis. It'll go ahead and show us for all the different surfaces, the tilt, the panel area that's potentially there, and it'll really help us go through and evaluate which of the different surfaces are worthwhile based on what the payback period needs to be. Okay, so it does a very good economic analysis based on the efficiency of the panels and really every different surface in terms of trying to give you some feedback about really which are the ones that are worthwhile working for. Okay. Another thing that's very good within Green Building Studio is if you're thinking at all about water. Okay, there's the whole notion of really what would the impact be of going through and changing to, for example, like a system that uses gray water or a system that uses rainwater potential. So what it'll do is it'll take your model and based on sort of the roof area and the rainwater data for the area, it'll go through and actually report for you just how much of the water that you're using you think it thinks that you can replace using these measures. So for example, if I say yes to rainwater harvesting, and this is the annual rainfall in Wollongong, here's our catchment area, it'll give us some sort of a rating of the efficiency. So I think there is some good support for you in terms of some of those things. In terms of actually the weather station data, let's kind of take a look at that because, okay, so do you have a city that you're near in China? Can you spell that for me? I just don't recognize the name. Near Beijing?
Yes.
Okay, so it looks like we're in Beijing and we do have weather station data available there. So if you choose this and we switch to Beijing, then it'll adjust the latitude and longitude, and it'll also just sort of capture the appropriate climate data and rainfall data too. Okay, so I think you ought to be able to localize it to the context there. Actually, then you'll flip the examples because I flipped everything so the sun was coming from the northern side, but by the time we're in Beijing, it's back to the northern hemisphere. Okay, so that's where I'd start with some of those things. Do you have some more questions or some more detail you want to ask about?
About the possibility of exporting IFC
Sure. Let's go ahead and talk about that, because IFC is actually a very powerful format for exchanging things between different BIM programs and different modeling programs. And that's actually something that improved quite a bit in the 2013 release. They have a whole new rewrite of the IFC exporting engine. So we can export things. And let me see if I can find it right down there. They have several different IFC formats available. I'm still looking at 2012 right here. Okay, let me go ahead, and we have a couple different formats here, but it's something that they're continuing to work on. Okay, so I don't have a lot of specifics about it, but I know that people are using it to successfully exchange data with some other programs, like ArchiCAD or Tekla. There's a number of other programs that people exchange IFC data with.
Okay, any last questions? Terrific. Well, thank you, Glenn. I think you've done a thorough job there in showing a range of our software titles there and the differences and similarities between them and how they can be used, especially for this solid decathlon challenge that the university here is going to be involved in. So thank you very much. This is recorded, so I'm sure everyone here will go back and rewind and review and learn more about your presentation. So on behalf of everyone here, Glenn, really appreciate your time.
Oh,
thank you for your presentation.
my pleasure, and thank you very much for having me. I hope I didn't overwhelm you with so much information. I really wanted to give the full range of things that were available, just to kind of tease your interest and let you know what's available. I realize that most teams won't really dive into all of those tools, but hopefully just knowing that they're there will give you some clues about some of things that might be applicable and how you can apply them if you do need them. Okay, so thank you for having me. I appreciate the opportunity.
And have a good evening.
So thank you for having me. I appreciate the opportunity. Hey, no worries. Cheers to you too. Okay, you guys take care. Bye-bye. Hey, no worries. Cheers to you too. Okay, you guys take care. Bye-bye.